James Clerk Maxwell was born in Edinburgh in 1831. Maxwell spent his early years at their family home at Glenlair in Dumfries and Galloway. He went to Edinburgh Academy when he was 10 years old. Here, he demonstrated an extraordinary ability in mathematics. Maxwell's first scientific paper was written when he was just 14 years old. Came from his interest in drawing oval shape using pin and string. Instead of simply observing the shape it was possible to draw, he formulated mathematical equations relating the variables to one another.
Maxwell went on to study in Edinburgh, London and Cambridge, where he experimented in color vision by mixing different colors of light together. It was at this time that he began to carry out the work for which he is best known, research in electromagnetic radiation. From extensive work over the following years, he formulated 4 equations relating electricity, magnetism, and light for the first time. This theory predicted the existence of radio waves.
Work and experiments. In 1856, aged only 25, he was appointed to the chair of natural philosophy at Marischal College, Aberdeen. At this time, he began work on another field of research, the composition of the rings of Saturn. His theories were only confirmed to be correct in the 1980s when the Voyager space expedition allowed closer examination of Saturn. Maxwell became Professor of Natural Philosophy at King's College, London in 1860. He remained there for the next 5 years. During a lecture, he demonstrated the first color photograph of a tartan ribbon using colored filters. In 1871, he took up post as the first professor of experimental physics at Cambridge University. He went on to help set up the Cavendish Research Laboratory, where many of his theories were developed.
In 1859, he was awarded Adams Prize of 130 sterling for his essay on the stability of the motion of Saturn's rings. He was bestowed with the Royal Society's Rumford Medal in 1860 for his work of color.
Maxwell died of stomach cancer at the age of 48. A moving of theory by P.J. Tate, Maxwell's friend and fellow scientist, appear in the proceeding of the Royal Society of Edinburgh. Maxwell is buried in Parton churchyard near Glenlair in Dumfries and Galloway. Considering his untimely death, Maxwell's exceptional achievements are even more remarkable. His name has not always been familiar to the general public. However, scientists universally acknowledge Maxwell's contribution to progress in the modern world. In our public poll, James Maxwell was voted the most popular Scottish scientist from the past.
Let's start with the first equation, Gauss law. The divergence means the field builds around a point, so in this case, T, which is basically equivalent to the electric field. The divergence is equivalent to the volume charge density. This is how much charge measured in coulombs exists over a given volume. The second equation, Gauss law for magnetic field. Magnetic field or the magnetic flux density is the same, which is 0. Means there is no isolated magnetic charge. We cannot find a magnetic monopole that have this type of distribution. The third equation is known as Faraday's law. The curl is a measure of how fields wrap around something. Imagine there is an electric field with a curl would exist. There's a flowing of electric field. So the curl of E, the rate at which an electric field swirls around something, is equal to the rate of change of the magnetic field.
The last equation is known as Ampere's law. Start with the curl of H equals to J. If the current flowing through a wire, then the magnetic field circles around the wire by the right-hand rules. The second term is the curl of the magnetic field is equal to displacement current density. Maxwell introduced a term which is the rate of change of the electric field divided time. This describes current going through a non-conductive path and gives rise to a circulating magnetic field. So we have two different phenomena, which is conductive current density as opposed to a displacement current density is equal to sigma E. If you have an electric field in a conductor, then you will have a current flows that we can actually get rid of J term.
Created using Powtoon.